Hello class, welcome to this lesson which is subtopic 1.3 geometric sequences and series, and this is the part 2. In this part what we will do guys is get a formula for the sum of the first n terms of a given geometric sequence, and this one is going to be a little more complicated than the formula before for the sum of the first n terms for an arithmetic sequence. This one's a little more complicated, so I'm going to do it very slowly. Try to pay a lot of attention to every single word I say. Let's start. So let me write a geometric sequence: u1 comma u2 comma u3 comma etc. And let's do this up until un. So this is a geometric sequence, and by the way, it can go on there, that's no point, but we only care about the first n terms of this geometric sequence, and we want to find a formula that could give me the sum of the first n terms of the sequence very quickly. I want to find some sort of expression in here so that this expression gets me this value rather quickly. That's what we want. Let's see if we can achieve that. Okay, how do we do this? We're gonna do the following. First, I'm gonna express this sum. I'm gonna just express it. So the sum of the first n terms of this given sequence is clearly u1 plus u2 plus u3 plus etc. plus un minus 2. You will see why I'm writing this in a moment. Plus un minus 1 plus un. There it is. Why am I writing n minus 2 and n minus 1 in here? Well, that's clear, right? Because every previous term, the index of every previous term is one less than its successive term. So the index, since this is the last term of my series, un, therefore the index of this should be one less than n. And this one, the index of this should be 1 less than n minus 1. That's why it looks like this. Okay, so this is in fact what I'm doing. I'm adding all of these terms and all the terms that are hidden in here. Okay, fine. Now, what's the trick in this type of deduction, in this deduction in particular? The trick is this, guys. I am going to do next, by the way, let me call this equation 1. And what I'm going to do next is reproduce or copy this same equation, all of this thing, and I'm going to put it in here below. I'm going to do that in blue. So let me just copy it, the whole thing. u1 plus u2 plus u3 plus all the things in between plus un minus 2 plus un minus 1 plus un. And even though it's the same as equation 1, I'm going to label it equation 2. Okay. Next, the trick is this, guys. This is gonna sound very weird at first, but this is how the trick works. Look at this equation. What I'm gonna do next is multiply both sides of this second equation. Both sides, I'm gonna multiply it by minus r. By minus r. So basically what I'm gonna do is this. Multiply all of this by minus r and multiply all of this also by minus r. And what is r in this case? Well, it's the same thing that we have been talking about. R stands for the ratio. The ratio of my particular geometric sequence. Remember that this is a geometric sequence. So u1 times r gives me u2, u2 times r gives me u3, etc. So that's what this r means. It's the ratio of this particular sequence. Okay, now let's see what happens when I actually multiply all of these terms by minus r. What happens on this left side? We get minus R times Sn. And on the right side, I'm going to multiply each of these, you see, each of these terms by minus R. So let's do it. We're going to get U1 times minus R. I'm going to get the following, minus U1 times R. And then this times minus R, I'm going to get minus U2 times R. And I'm going to keep doing that. U3 times R minus etc. And then this times this, we will get the following. So you get the idea, right? We have to be very careful in mathematics because the missing of a single symbol, just a single symbol, can bring everything down. Okay, so there you go. I already multiplied the second equation by minus R in both sides. Okay, good. Now let me erase this previous line or equation. Let me just erase it. We don't need it anymore. What we got out of this equation was this other equation. And now I'm gonna try to put this back again in this position just below this equation, and I'm gonna try to be very careful to put every single term on its corresponding one below the corresponding one on top. So this one corresponds with this, that's why I put it here. This one corresponds with this, so I'm gonna put it right here. This one corresponds with this, so I'm gonna put it right here, and so on. This one corresponds with this. You see, this is a very careful process. If you don't do it carefully, you're gonna fail. This one corresponds with this one corresponds with this, and this one with this. Okay. And again, let me call this equation 2, just for reference. Okay, fine. We don't need this anymore. And now let's look at this, guys. Look at equation number 1. U2, look at this term, U2. By definition, U2, by definition, you must agree that this is equal to U1 times R. Okay, so this and this are exactly the same. Exactly the same. Now, U3, by definition, is U2 times R. This one, by definition, is UN minus 3 times R. This one is UN minus 2 times R. And this last one is UN minus 1 times R. You can pause the video some seconds and understand what I just did. All of these yellow terms, this is equal to this is exactly equal to this, and so on for the rest. Okay, so I'm gonna erase the white terms and I'm gonna replace them by their yellow counterparts, which are exactly the same. I repeat, they are exactly the same. Here we go. There it is. Okay, and we can eliminate these ones again. And I know that you're thinking maybe you have already your brain hurting, but due to all of this, so just bear with me. We're almost done, guys. Okay, now look at these two equations, guys. Equation 1 and equation 2. what I'm gonna do next is the following. I'm going to add both sides of these equations side by side. What I mean is this. I'm going to add all of this and all of this. Okay, I'm gonna add this to this, and I'm gonna add all of this stuff to all of this stuff. So right side plus right side and left side plus left side. And you're gonna observe that something very peculiar will happen when I do this. When I add this and this, what am I gonna get? I'm gonna get Sn plus minus this number, I will get minus Rsn. Okay. And the weird trick, or the surprising fact will occur on this other part. When I add this right side and this right side, when I put them all in the same side of this equation, something peculiar will happen. What will happen is this, guys. Look at this. Look at this term and look at this term in here. Tell me, when we add these two things together, what's going to be produced? We have minus u1 times r, and we have plus u1 times r. They're going to cancel one another. Can you see? Because one is negative, one is plus, and they are virtually the same, other than the sign, right? And the same goes for these two. Look, this one will cancel this one. You see, this one will cancel the one that comes next in here. And now let's go to these other ones. This one will cancel this one. This one gets canceled with one right here. And this one will cancel this one. Okay, so basically, guys, listen, when I add the right sides of equation 1 and equation 2, when I add the right sides and write the final answer in here, what I'm going to get in the very end is just this term in here. Like this is going to be the only surviving term, u1, and this other last term in here, minus un times r, because all of these other terms in between, all of these that I have been circling in white, they're gonna cancel one another. The only remaining terms that we will have is u1 and minus minus un times r. So that's the only thing that I'm gonna get as a result of that in this side. So let me write that down. We will get u1 minus un times r. Okay, that's what we have. We have this equation number 3, and from here it's just a walk in the park. We have already passed the difficult stuff. Now look at this, guys. We have this term and this other term. What is the common factor? It's Sn, as you can see. Sn that multiplies 1 minus r. So let's factorize. And in here we have u1 minus un times r. And finally, we just isolate what I want, which is Sn. That's what I've been looking for. Sn will be equal to u1 minus un times r over 1 minus r. There you go, guys. This is the final solution. I mean, this is the final formula for my for the sum of the first n terms, because this is what we were looking for. I said to you, we want to find a formula that will give me Sn, can you see, in terms of u1 and r and un. By the way, we already know what un is, right? Un, if you remember from the previous lesson, un is equal to u1 times r to the n minus 1. So we can use this un and replace it right there. So we will have u1 minus u1 times r and minus 1. You see, all of this is equal to this, according to this. You have to stop the video and make sure, because I know that you can get mixed up. It's a little confusing. Times r over 1 minus r. And finally, we can get the following simplification. Let's multiply this parenthesis times r. What's going to happen? We're going to get u1 minus u1 times r to the n minus 1 times r. And when you add the exponents of this one and this one, you will get times r over 1 minus r. And in the very end, you will have Sn equals, in here, what do we have as a common factor? We have u1. u1 that multiplies 1 minus r. I'm sorry, this is r to the n. I'm sorry. Because when we add this to this, we get n. And so we get u1 that multiplies 1 minus r to the n over 1 minus r. And this is my final formula. There you go. This is the sum of the first n terms of a geometric sequence given in terms of u1, the first term, and the ratio r. There it is. I know this was complex, guys. You need to check this maybe 2 or 3 times more in order to fully understand it, because I do need you to fully understand this process and to carry it out on your own. I know it's complex. I know. I understand. So take your time. Don't worry too much if you did not fully understand. If you did not fully understand this thing at the first site, don't worry. Don't worry. Okay, so this is the formula, guys. Let's stop right there. Let me go back with you.